Greetings, advanced students, and welcome back to Wednesday's edition of Distant Learning with Mr. Wong. Today's lesson is 13.2, Adding and Subtracting Linear Expressions. Homework is 13.2, available on eCampus. It is a 2-page document. It contains review problems as well as questions from this lesson. Let's proceed. Adding and subtracting algebraic expressions. What is a linear expression? A linear expression is an algebraic expression in which the exponent is a variable of 1. For example, linear expressions are negative 4x, 3x plus 5, and also 5 minus 1/6 x. Notice that the variables have no exponent, or rather an invisible 1 as an exponent. Nonlinear expressions have variables with exponents greater than 1. X to the power of 2 is not a linear expression. Negative 7x to the power of 3 plus x is a nonlinear expression. And x to the power of 5 plus 1 is also nonlinear. Go ahead and write this in your notes. Pause the video now and then resume once you've finished. Let's move on. Linear functions and equations graphed form a line, a straight line. Nonlinear expressions will form a curved line. Adding linear expressions. Find each sum. In this problem, we have the quantity x minus 2 being added to the quantity 3x plus 8. Let's first look at the vertical method by aligning like terms vertically and combining them. In this first case, we have x minus 2 stacked vertically with adding 3x plus 8. In this example, we will just do the arithmetic without rewriting the first expression as adding the opposite. If we combine x with 3x, we'll come up with 4x. If we combine 8 and a negative 2, we get positive 6. Very similar to the scenario we used in class as an example of good guys versus bad guys. Now let's take a look at adding linear expressions using a horizontal method. And what's us to find the sum of the quantity negative 4y plus 3 plus 11y minus 5. It asks us to use the properties of operations to group like terms together and simplify. It wants us to rewrite the sum by using the commutative property. That means rearranging the terms so that all the like terms are together. In this case, we'll move this plus 11y to the front so it's next to the minus or negative 4y. We'll then move this plus 3 next to this minus 5. And then we group like terms together. In this case, all our variable terms and our constant terms. And we combine like terms. Negative 4y's plus 11y's, we have 7 positive extra yo-yos. And again, 3 minus 5 is negative 2, or the expression 7y minus 2. Let's take a look at a more complex problem requiring distributive property. Horizontal method. Use the distributive property. We have to first figure out 2 times negative 7.5z plus 3. Again, there are two groups of these, so let's multiply and figure it out. 2 times negative 7.5 is 15, but with a negative z. And 2 times this plus 3 is plus 6. And let's write that 5z minus 2 there. At this point, we want to rewrite any subtraction part as add the opposite. In this case, negative 15z remains the same, because it's negative, plus 6 remains the same, plus 5z remains the same, but we turn that minus to an addition sign, and change the 2 to negative 2. We use the commutative property of addition, again, regrouping the like terms together. Put all the z's together, and then the constants, or numbers, together. Then we combine like terms. Negative 15z plus 5z gives us negative 10z. And 6 plus a negative 2 gives us positive 4. Let's take a look at the vertical method. Again, we still must use the distributive property. So we'll get negative 15z plus 6. We write the bottom portion as adding the opposite. And then we combine like terms. Stacking these together, we'll end up again with negative 10z, and combining 6 and negative 2 gives us positive 4. I believe firmly that the vertical method keeps everything better organized because it stacks all the like terms together. There will be occasions where you still have to use commutative property of addition to switch the terms around so that the like terms are actually above and below each other. Let's try some of these on your own. Find the sum. Remember to rewrite any subtraction parts as add the opposite. At this time, copy these 3 questions now and make sure there's ample room below each to solve and show the work. Again, remember to rewrite any subtraction problems as add the opposite. Go ahead and pause the video now to copy the questions and solve these showing work at each step. Then resume the video once you've completed the task. Welcome back. Let's check our answers in a step-by-step fashion using the vertical method. Question 1. X plus 3 plus 2x minus 1. We'll first rewrite the second portion as adding the opposite. 2x remains the same, but minus becomes a plus, and that 1 goes the opposite, negative 1. And then we combine it with the x plus 3, stacked vertically. At this moment, we don't need to employ the commutative property of addition because all the terms are already stacked. 2x plus x is 3x, and negative 1 plus this 3 is positive 2. Let's check question 2. Negative 8z plus 4 plus 8z minus 7. Even at this time, I noticed something special. I noticed a negative 8z along with a positive 8z. These are his opposites, and will probably cancel each other out. The final problem will then just be a 4 plus a minus 7. But let's follow the rules step by step. Again, remember to rewrite any subtraction part as add the opposite. That means that this 8z minus 7 will become 8z plus negative 7. And let's stack this first part, negative 8z plus 4, right underneath. Again, we can combine these 8z and negative 8z to get 0, and negative 7 plus 4 gives us negative 3. And finally, question 3 does require some distributive property. That'll be the first step before we rewrite any parts as add the opposite. So we have to distribute this 2 and multiply it to this negative 5n, as well as multiply the 2 to this plus 3. We get, as a result, negative 10n plus 6. We also rewrite this 4 minus n as 4 plus negative n. Let's go ahead and stack these and combine them. At this point, we notice that our terms are not exactly below and above each other. Go ahead and use commutative property to make that negative n in front and this 4 after. Now we can combine like terms. Negative 10n plus a negative n means you have more negative n's. Negative 11n to be exact, plus 10 as a result of 6 plus 4. Did you get the answers right? Great. Let's continue. What about subtracting linear expressions? To subtract one linear expression from another, add the opposite of each term in the expression. You can use the vertical or horizontal method. In this case, let's look at Chewbacca and what is he saying. This translates to, you are pretty much distributing that minus sign as opposite of everything inside the parentheses. Let's take a look. We'll be using the vertical method and aligning like terms vertically to solve these. So we'll just stack the first part, 5x plus 6, minus the second part, negative x plus 6. Again, we need to rewrite everything inside as the opposite, changing this minus to a plus, and changing all the terms inside as opposites. That means that it'll be positive x, and this plus 6 becomes minus 6. Now we will rewrite this minus or subtraction part as add the opposite. At this point, we can already see that these would cancel out without any work, and we'll get 6x as a result. Let's follow the steps in case we get more complicated problems that will require us to add the opposite. So we will keep the x, change that minus to a plus sign, and that 6 becomes a negative 6. Again, now we have a scenario where we have opposites, which combine to get 0, but also 5x plus x equals 6x, the same result as we got before. Go ahead and pause the video now if you wish to copy these as notes to use later. Remember, you can always rewind the video to watch this part to aid in completing the homework assignment. Let's solve another subtraction linear expression problems using the horizontal method. We will be trying to subtract the expression 7y plus 5 minus 2 times the quantity 4y minus 3. The first thing we have to do is make sure that we use the distributive property. We have to distribute this 2 with the terms on the inside. There's 2 of these 4y's and there's 2 of these minus 3's. When we do that, we get 8y minus 6. Let's rewrite the rest of the expression in the front. Now we will rewrite it with adding the opposite. When we see the subtraction sign, we're pretty much going to be adding these together. So add it, and the opposite of 8y, and the opposite of minus 6. We'd get plus negative 8y plus 6, and again the original portions here with 7y plus 5. We'll use the commutative property of addition to group our like terms together, putting the y's together and the constants. At this time, we combine like terms. 7y plus negative 8y gives us an extra negative y, plus 5 plus 6 gives us plus 11. Let's look at a word problem that has us subtracting linear expressions. The original price of a cowboy hat is $D. Use a coupon and buy the hat for D minus $2. You decorate the hat and sell it for 2D minus $4. Write an expression that represents your earnings from buying and selling the hat, and then interpret the expression. It asks us to use a model. Our earnings is the selling price minus the purchase price. So our selling price is 2D minus 4, and we find the difference by subtracting what we paid for the hat, D minus 2. It wants us to add the opposite. So we're going to add the opposite of D minus 2, which is negative D plus 2. When we group like terms together, we're going to be combining this negative minus D, 2D, and this minus 4 with this plus 2. Our result will be D minus 2. Interpreting this final expression, you earned D minus $2. You also paid D minus $2, so you doubled your money by selling the hat for twice as much as you paid for it. Let's try a practice problem. Find the difference of m minus 3 minus negative n plus 12. Employ any method you wish, either solving vertically or horizontally. I'll be showing the vertical method of solving after you try this one on your own. Pause the video now to complete this question and then resume once you've completed the task to check your answer. Welcome back. Let's see. Let's stack these vertically with the first quantity term minus the second quantity term. M minus 3 minus negative n plus 12. We're going to rewrite it as add the opposite of the first term on top as well as the second term on the bottom. So the first top part, m minus 3, will become m plus negative 3. And the bottom one, we're making the opposite of everything inside from this first minus sign. So instead of subtracting, we'll be adding the opposite of negative m, which is m, and the opposite of plus 12, which is minus 12. Now we write it as add the opposite for this minus problem on the bottom. The first portion remains the same at the top, m plus negative 3, but the bottom one will become m plus negative 12. At this time, we will combine like terms. M plus m is 2m. Negative 3 plus negative 12 is negative 15. And since we know that adding the opposite is also coming from a subtraction problem, we can also have the final answer of 2m minus 15. This concludes the lesson. Let's check the homework. The homework this week for this lesson on Wednesday is review questions 11 through 15, followed by the lesson questions 17, 18, 23, and 29. Please show every step when working on this important skill. Remember, this is a 2-page document on eCampus. Do not forget about the second page. And for an extra credit opportunity, as part of your homework, please write what you saw on the last slide between the answers. You saw something flash and then disappear. Write that down as part of your homework to receive extra credit. Make sure to try your best to complete this assignment. It'll be due by Friday evening, April 24th, 2020, 11:59 p.m. Until next time.